It's the same like that one.
9.
It's number 9.1. It's 9.1, sir.
So
Can you do question number 9?
yeah, what is the maximum power with no field excitation? Remember we said that what's it now? Is Ayman.
It's a reluctant.
Pardon? EV over XD.
Without the entry, no field, you left with a reluctant power.
V squared XD minus XQ over 2XD XQ sine 2 delta. Now this is your excitation voltage and this is your reluctance voltage. Okay?
Yes, sir.
And now the only thing that remains if your excitation is switched off is that.
Yes, sir.
Your reluctance power. Okay.
Yes, sir. The problem that I had is when I calculate the power factor.
No, there's no power factor there.
You need the power factor. If you can check the formula, the questions, they say determine the value of this power, the armature current, and the power factor for this condition.
Yeah. So the power factor for that
So,
yeah, it's going to be at 45 degrees.
yes, sir.
Okay. So sine 2 delta is going to be 90.
Yeah.
Okay.
Yes, sir.
Great stuff. Right. Design. Any questions there?
So the problem that I had now.
Oh, you said
you cannot use I find IA and ID and IQ.
Where?
Then now for 9.1, I find IQ using those formulas, the one that you were using before, then ID. Then I find IA using a Pythagoras rule, the one of root of IQ squared plus ID squared. Then I get that IA. Now I need to get power factor. I use ID equals to IM sine of power factor plus maximum load angle. Yeah. So I got it, but now when I use the one of IQ equals to IM cos, it does not work. I don't know why.
Hey.
Then I try to use the one of
what? Oh, you're breaking up.
So I try to use the one of IA is equals to IQ plus or minus JID.
Yes.
Yes, but it does not work also. Only one is working, so I don't know why.
Okay, I'll check it and let you know. I don't know why. It should.
Okay.
Okay. And
okay, 9.2, sir. 9.2. Rated power output with minimum excitation. Determine this minimum value of the excitation.
Yep. So, what is the minimum excitation?
Meaning of what?
Minimum excitation.
Minimum excitation. Is the one that is the same as that one, where your beta is equals to load angle, which is equals to 90.
Okay. And then?
And then which means your P mean is equals to your E mean times V over X or
Yeah.
Z.
Yeah.
Yeah. So where will I get, what is my P mean? Because that's the thing that made me to not calculate it, because I don't have that power. Rated power output with minimum. Oh. I see two unknowns, which is P mean and E mean.
Okay, when is your power maximum or when is your power minimum?
Sir?
I say, when is your power minimum?
When is my power minimum? What I know is that when you have a power maximum,
Yeah, then sine delta must
you
be
have your. So can you write, your voice is cutting?
Yo. I don't know what the hell is going on with this internet today. Because I struggled in the previous from 6 o'clock as well. If we look at the power developed, né? EV over X sine delta.
Yes, sir.
When is that going to be a minimum?
Sir?
Yes.
That one is when it's maximum.
Yeah, when delta is 90.
And then if ever it's minimum, which means so there it's 90 when it's minimum.
As maximum, but because of
So
sine.
you're saying 90 is equals to 1. That is why you have P developed.
Then we have the graph. If delta is 90 degrees there, then sine delta is 1. That'll be the maximum. Let me just check here in the book. Maximum load angle.
Yeah.
That doesn't have much. Oh, leave that one, I'll let you know. I don't see it here now immediately. But that question is a bit difficult, no? I think you can leave that for the exam. Question 9.
I said, I'll say 9.2, please.
Like I said, when I'm done with it, I'll email you. WhatsApp you.
Okay, 8.4. The last question from Silent Pool, 8.4.
8.4. Yeah.
If the shaft load is removed before the current is reduced to zero, determine the resultant supply current in per unit and the supply power factor.
So what is going to happen if we remove the load before the current is reduced to zero? What's going to happen? So in other words, we will have a current there. All right, I need to see factor 0.8 lagging. Oh, shit, we're running out of time again. All right. You got all the first ones right now.
Yes, it's only 8.4.
Let me think. Determine the result. So can we calculate E when it's full load? What is the power then?
You want E is 0.825, angle of negative 22.83.
Okay, that's E, no?
Yeah, that's the first E. Or you want the last one?
No, that one of, will it stay in synchronism?
So the other E is 0.727. That's the one that we use when we calculate.
0.727.
Is 0.727. Yeah, 0.727.
Yeah.
Yes.
Which current is?
The same angle.
What is that voltage?
Sir?
Yeah.
I can't hear you.
That 0.727, which voltage is that?
That one, the 0.727.
Yeah, that's your
Is
induced.
the induced EMF. The second one, the first you must get the induced EMF, then you get your ID and IQ. After you get another induced EMF, that's the one that you're going to use when you calculate. Yeah.
Okay, that's just to get your angle.
Minus 22.83 is the same load angle.
So we don't want that. All right, so now hello, can you hear me?
Yes, sir.
Okay. Oh, you got me there. I have to think about that. If it's reduced, in other words, then at that instant, your output power will be the same as for full load, né?
Okay.
No, I'll let you know. Damn, you've got me tonight.
Oh, you let me know. Okay. You have 4 questions to answer.
Oh,
Okay, now you can do design unless someone has a question from Silent Pole.
I think you covered it.
I will ask questions after you are done teaching design.
Yeah, but you've got the design stuff already. Is there any questions? You said you calculated something with millimeters, cubic millimeters. Isn't that? Or not?
Sir?
Wasn't you that said that you calculate something in with millimeters instead of cubic meters? There was somebody that asked that.
I can't. Yeah, your voice is cutting.
Hey man.
Serious, right. Can you write what you are saying? It will be better. Serious, I can't hear you. Wait.
Somebody said they calculated in cubic millimeters instead of cubic meters. And the answer was not the same.
Millimeters instead of cubic millimeter. What are you talking about, sir?
The area of the volume. Let me see. Hey man. Machines for. All right, doesn't matter. So, a big thing for the design is you must know your formulas. So, for a single phase transformer, you get S is 2.22. That is for a shell type or a core type. Single phase. Then when we get to the 3-phase transformer, S is equal to 3,33 B max AI F.
Sir, are you writing?
What?
I see your face. Can we see the way you're writing?
Hey, why? This thing is screwing around. So you don't like my face? Be careful what you say now. Now you're playing around with your mouth.
It's not like that, sir. Can you shift your picture? Can you move that page?
Okay, that first part is not important. So then when we get to a 3-phase transformer, we get again AW, KWJ. That's for a three-phase core type. And for a shell type, it is 6.66 core and shell 6.66 with all those stuff. B maximum, the area of the ion of frequency, area of the window times KWJ. So that's for a shell type transformer. And that is a core. Three phase and single phase. Shell and core. This thing is now very terrible.